Hello class 10. Today we are going to learn numericals on electrical power and household consumption. So let's directly move on to the numericals from the exercise of the book. Question number 1. An electric bulb of resistance 500 ohms draws current 0.4 ampere from the source. Calculate the power of the bulb and number B, the potential difference at its end. So first we'll write down whatever is given in the question. So the resistance of the bulb is equal to 500 ohms and the current drawn is equal to 0.4 ampere. Now we have to find number A, the power of the bulb, and we have already discussed earlier that the power is equal to I squared R. I in this case is the current, which is 0.4 ampere, and resistance is 500 ohms. So putting these values as I squared R, you'll get 0.4 whole squared into 500. Now 0.4 whole squared is equal to 0.16 into 500. Multiplying this, you'll get 80 watt. So 80 watt is the power of the bulb. Number B, we have to find the potential difference at its end. Now the potential difference is V, which is equal to IR from Ohm's law. I into R means the value of current 0.4 will be multiplied with the resistance 500 ohms. So when you multiply, you will get 200 volt. So that is a voltage or potential difference at the two ends. So this is how we do this type of question. Next we have question number 2, which says a current of 2 ampere is passed through a coil of resistance 75 ohms for 2 minutes. Question number A, how much heat energy is produced, and number B, how much charge is passed through the resistance. So the solution is, we write down whatever is given. Current is equal to 2 amperes, resistance is equal to 75 ohms, and time duration is equal to 2 minutes, that is equal to 120 seconds. Remember, whenever you need to convert time, always convert it in terms of seconds. This is not discussed. Heat is equal to I squared RT. Just remember this formula. Heat produced by the flow of electric current is equal to I squared RT. I gives the current, R is the resistance, and T is the time duration at which the current flows. So I squared is equal to 2 squared, that is the current. R resistance is 75, so that is also multiplied into 120 seconds. So when this is simplified, 2 squared becomes 4 into 75 into 120, which is equal to 36,000 joules. Remember, the heat energy, the unit is equal to joules. Number B, charge. You have to find the charge, and charge Q is equal to I into T. So I into T means current multiplied by the time in seconds. So 2 into 120 seconds, that is equal to 240 coulomb. So that is the amount of charge which flows through the conductor at that time. So this is question number 2. Now we move on directly to the next type of question, that is in question number 9. We have a bulb rated 12 volt and 24 watt operates on a 12 volt battery for 20 minutes. Calculate the current flowing through it, and number 2, the energy consumed. So we write down whatever is given. The voltage is 12 volt, power is 24 watt, and time duration is 20 minutes, that is equal to 20 into 60, 1200 seconds. Now part 1, P is equal to VI, that's the formula we have learned from power. Power is equal to V, potential difference, voltage into current. That means I is equal to P by V. So P by V, P is equal to 24 watt and V is equal to 12. So that is equal to 24 by 12, which is equal to 2 ampere. So 2 ampere of current will be flowing through the bulb. Okay. Next, the energy consumed. So how much energy is consumed? We have already learned in the previous class that energy is equal to power into time. So power is equal to 24, that is 24 watt, into time is 1200 second. So when you multiply this, you will get 28,800 joules. So that much energy is consumed. Next, question number 20, which has appeared in the year 2018 ICAC. An electric iron is rated 220 volt. 2 kilowatt is the power. If the iron is used for 3 hours daily, find the cost of running it for 1 week if it costs rupees 4.25 per kilowatt hour. So, solution: voltage is equal to 220 volt and the power is equal to 2 kilowatt. 2 kilowatt of power means it withdraws 2 kilowatt of energy every second. So for 3 hours, energy consumed every day or daily will be equal to 2 kilowatt into 3 hours. That will give us 6 kilowatt hour of energy which is consumed. So if this is the energy consumed daily, and here we are discussing about 1 week of energy consumption. So for 1 week, the energy consumed is equal to 6 kilowatt hour into 7. That will give us 42 kilowatt hour. Now 1 kilowatt hour is the unit, as we have learned earlier. So cost of 1 unit of electrical energy is equal to rupees 4.25. Therefore, the cost of 42 kilowatt hour of electrical energy will be equal to rupees 4.25 multiplied with 42. That will give us rupees 178.5. So this is how we solve this kind of problems, and there are similar type of questions that is given in the book. So you will do as an assignment from page number 212, numericals, question number 4, 5, 6, 10, 11, 13 and 15. Okay, please don't try to copy these numericals from any app or any solved books. Okay, please try to do this by yourself and try to learn it how it is done. Okay, thank you.